This is your PowerPoint on Conics. Sorry, yesterday my geometry classes had a test, so I got like a million emails and stuff like that, so I was bombarded with them all day. The first conics that we're going to look at are parabolas. We're really just going to do this one pretty quickly because we've obviously spent a lot of time on parabolas when we've been doing the quadratics. So this format, because it is a conic, is a little bit different. There's two new terms, a focus and a directrix. Those are going to be pretty important because when we do the next conic circles and etc., those terms will come up again. So you do need to know how to find those. But graphing them via this method is not really that important. You can do them the other way by just finding the vertex and the axis of symmetry. But you do want to know what these terms, directrix and focus, are. Just get used to using those terms. All right, so on to slide two. This is the old versus the new. With the old parabolas, it was only up or down that they opened, and we were used to the x term being squared. Now with the new parabolas, the other type, you're going to see that the y term is squared, and those parabolas are going to open to the left or to the right. Excuse me. As you can see, these vocabulary scrolling in here, the focus, excuse me, is going to be this point here. Um, my my pen is en route. I ordered one for my computer. Um, but this is the focus. And the focus is a point, and it's always inside the parabola. It's the definition is in the packet that you guys have. It's a point that's considered equidistant from any point on either side of the parabola. Again, really not too important when it comes to the parabola or graphing it, but it is a term that's important in some of the other some of the other conics that we'll be looking at. And the directrix is a vertical or horizontal line that will never intersect the parabola. So it's either going to be like underneath it here. It'll never be like this where it intersects the parabola. It'll always be like right under the vertex, or obviously if the parabola opened, let's say it opened downward, my skills here. If it opened downward, then the directrix would be going that way. It would never actually intersect the parabola itself. All right, parts of the equation. In the equations, HK is the vertex, and again, it'll be set up two different ways. It'll either be y equals ax squared plus k, yada yada, or it'll be x equals. If it is y equals, that's like our standard parabola, so that'll be the one that opens up or down. If a is positive, it opens up. If a is negative, it opens down. So that's just like the normal. Up, and if it's negative, it'll open down. For the stylist is coming tomorrow. um, for the x squared parabolas, I'm sorry, for the y squared parabolas, those are the ones that are going to open either to the left or right. And if a is positive, it's going to be a parabola that opens upward. Oh, that worked out pretty well. I clicked first. Let's see if that works again. And if a is negative, oh no, that didn't work. Oh, well, thought I figured out something. And if a is negative, it's going to open to the left. You know, kind of like common sense for positive y, positive x, etc. Anyway, the axis of symmetry, if it's our regular parabola, it's just going to be our up down that we're used to. It's going to be x equals h for the axis of symmetry. And if it's, excuse me, one of our side opening parabolas, it's going to be y equals k. And then here are the formulas for the focus and the directrix. I would write those down because on the next slide, there are some examples and you want to make sure you have those formulas handy. They are on the first page in the packet, but you know, just in case you want to write them down again, but they are on the front page of that long-term packet. All right, so let's go to the next page and look at some examples. Now, example one, excuse me. So first thing you should notice is this is y equals. So because it's y equals, again, that's what we've been used to when we had y equals x squared, yada, yada. So that's our basic parabola that's going to open up or down. Hopefully that's pretty self-explanatory. Um, and then I'm asking you which one of these is the vertex, the axis symmetry, the focus, and the directrix. I'll give you a few seconds to try that. At least the first three, the multiple choice, you should be able to to do something with without, without much assistance. But the focus and the directrix, you'll probably need a little bit more help on, and that we'll do on the next page. All right, so here are the answers. Again, because it's y equals, it's going to open up. The vertex is HK. So HK, again, if you look at the format, let's see what color I have here. It's black. Yes, praise God. So this is your HK for the vertex. Oh, that one doesn't look bad. Stylus coming soon. They didn't have any in Staples. I had to order it. It's for the season, everything. Um, anyway, HK is the vertex. So if you look at the formula from what you hopefully wrote down already, it's negative HK. So in the formula, even though it's a minus here, it's the opposite of what H really was. So your vertex would have been the opposite of this, which is going to be 4. Oops. And the K is the same. There's no sign change for that. So I did the graph, just like the normal way. I stuck the directrix in there. Again, it's not really something I'm going to look for on a graph. You don't need it, but this is the directrix, that line. Again, it's underneath the parabola. And the focus is that point right there. If you can see it, it's right above the vertex. So it's inside. Anyway, the formula for the focus is here. The focus again is a point. So here's the formula. Where's my cursor? There it is. Oh, it disappears on the white. But anyway, excuse me. Here's the formula. So with the formula, I just immediately just wrote down what H, K, and and A were, and then I just plugged them in. And when I get it, this is my focus here, and my directrix. Again, I already know what K, A, and H were. I don't need H for this one. Actually, I did, but I guess I didn't write it down. But H is up here. So anyway, you just plug them in, and then you get your answer. So that's how we get that. Let's look at example 2. All right, so for example 2, this one will be a little different for you because it is in the different format, where the x is squared, not the y. I'm sorry, where the y is squared, not the x. So that should let you know it's the different one. So that means it's going to either open you should be thinking either to the left or the right, and hopefully you make the right decision on that. And then the vertex is some combination of the 3 and the 7. Try to get every sign change there. And again, you have to take into consideration the setup. When it's y equals, this is the k term, and this is the h term. So it's kind of reversed. So you need to be careful with that. And here's the next slide with the answers. All right. So here's our next slide with the answers. Again, it's positive. There's no negative here for A. And remember, if there's nothing there, then it really is a 1. So it's right. My vertex, again, it's HK. The thing that's in the parentheses is the opposite. So because it's a positive here, that meant it really was a negative, because it was minus and minus. Vertex, and then the axis of symmetry, again, if it's x equals, that means it's going to be, oops, I did this wrong. Sorry, I'm just noticing that. I selected the wrong one here. This should be, what graph is this? Oh, never mind. This is right. I'm sorry, I'm looking at it wrong. I'm looking at the 7, but I forgot this is forgetting myself, it's going horizontal. Thought I put the wrong thing here. But the axis of symmetry, in this case, is going to be an x equals line because it's going to open to the left or right. And it's going to be negative 7 for that. And then my directrix is the negative 3.25. I didn't graph the axis of symmetry, but the axis of symmetry would be, oh, that's a bad line, would be like that line going up the middle. I wasn't paying attention initially. I thought that was the directrix in my notes here. But so that would be what you would do. Again, you have to indicate from the formula what H, A, and K are. Those are the things you plug in, and you figure out the focus and the directrix. Again, the focus would be like on the inside of the parabola here. It's pretty useless for most purposes, but with some of the other conics, they're more relevant. Third slide, third example. You should know the direction it opens, the vertex, axis of symmetry, and the focus and the directrix. Take a second, try it before you go to the next slide with the answer. Okay, as I am coming to the slide, I realized, made a mistake, my bad. The vertex should be HK, and these should be opposite. This should be the opposite here all the time, the one that's in parentheses. So it should be, oh my gosh, let's see research. I mean, this situation sucks. So it's going to be -2, -5. So this is wrong, and therefore my graph is wrong. Doggone it. Should have looked at it before I did it, before I started to record. Oh well. But that would be my vertex. Again, that should be the opposite. So it should be -2, -5. And therefore, this whole graph should probably be over here. Oops, it is. Such a beautiful parabola. So, my bad. Ignore that one. So again, that should be -2, -5 for the vertex. And it should open down, etc. And it should be over here. Obviously, you could do better than that, but that's what it should look like. And then here's my work for the focus. Again, I need to identify H, K, A, the things required. H, K, A. Well, for some reason, I didn't write this one as a point, but the focus would have been, let's see how I do. Come on, stylus gods. It should be H, which was do-si-do. Oh. And let's see if I can do it. -5.1. Whoa. That's a point. All right. Anyway, that's as best as it's gonna get right now. But anyway, that is the focus, and then the directrix would be x equals 4.9. Oh, that's crazy. All right. Anyway, next slide. Next example. Example 4. The same first 3 questions. Direction it opens, vertex, axis of symmetry, focus, and directrix. And here comes our answer slide. Hopefully I didn't make a mistake. Let's see. She looks good on this one. All right, so for this one, again, it's x equals. So x equals indicates it's going to open left or right. So hopefully you had one of those 2 options. Positive A means we're going to open to the right. So your answer should be right. Vertex, again, when it's x equals, this is kind of reverse, where this is the K. And then like the H is over here. So it's like plus H. Ooh, look at that. That's a good, oh no, that's a good looking plus sign for a minute. So the H is over here. And remember, the thing that's in parentheses is always the opposite. And again, the vertex is HK. So H, comma, K. I hope it's an early delivery tomorrow, so I won't have to do this without my pen tomorrow. Anyway, so that means this is our K. Again, it's the opposite, so it's really a positive 5. And H, if there's nothing over there, it's 0. So our vertex is going to be 0 for H and then K. The axis of symmetry is going to be, again, you don't have to necessarily graph it, but I'll put it on the graph if you want to see it. This is our axis of symmetry. That line is actually almost straight. So that's our axis of symmetry. And here's our formula again for the focus and the directrix. Any questions on that? Hopefully not. Again, you have to identify those basic things being H, K, and A, and basically plug into the formula. I get 0.5 for the x value, and then K is just 5. The directrix, it's x equals -1/2. Next slide. So this is the last example. Try to give you one of each type, looking a little bit different. Hopefully this will guide you through the packet, at least the first few pages on the parabolas. Here's our answer slide. I'm sorry, that might have been a little quick, but here's our answer slide. X is squared, so again, that should lead you to go towards the left or the right. I'm sorry, not x is squared, y is squared. So that should lead you towards the x of the left or the right. It's a negative a here. So since a is negative, we know this is going to open to the left. And again, if it is y equals, it's k that's in the parentheses with the y, and then it's h on the outside. So there's nothing in parentheses with the y, which indicates that k was 0. So k was 0. So that's the hk from our vertex. Let's make that h. Okay. All right. So I don't know why I'm just not using my fingers, but it's just as bad. Anyway, so h was -5. Again, if it's the outside thing that's not in the parentheses, it's the same sign. If it's in parentheses, you change sign. So this is our correct vertex. I think I got it right this time. Axis of symmetry is y equals 0. Again, it's whatever the y value is or the k value. And then again, I get my focus and I get my directrix using these values, h, a, k. Plug them into the fabulous formula here, and it gives me the points. This one worked out pretty good. I picked a pretty good one this time because it's actual, not a decimal, but it ended up being -6, 0. So there's my focus. Again, it's always inside the parabola. And there's my directrix, this random line here. Again, completely not important to the graph process. All right, so let's move on. There's a couple other questions in the packet. In the first few pages dealing with quadratics. One of them is relating to standard form, and we've done that quite a few times, getting it in standard form. When you want to get something in standard form, you just want to get the y. Normally it's y alone, but like I said, because we have the two forms now, it could technically be, I should have written this up here, it could also be x equals, this will take an hour. The whole thing will be done by the time I get this written out, but it will be a y squared. Hopefully you're looking at the equation on the bottom and not me and my stylus difficulties. By plus c. Yay! Anyway, if you're looking at the equation, hopefully you noticed, again, in this case, you want to get the y or x alone. It depends on which one is not squared. So in this case, obviously, this y is not squared either. But since it's the y squared, that's the thing you want on the other side, basically. Remember, you never move the x squared term or the y squared term, because if that's negative, then it's supposed to be a negative. And if you move it, and change everything else, that's always going to be incorrect. So you never move the square term, so you keep that there and focus on moving everything else. So in this case, I want to move the x away. I want to move the y's back to the other side. Went through that whole process, and there's my answer. You can reverse it. I'm going to just attach the regular PowerPoint as well, so we can go through it a little slower. And on this side, since it's an x squared, the thing we want to get alone is the y. So I move the 2, and then I divide everything by 5 to get just the y. And this will be standard form. It's pretty straightforward. Hopefully everyone's okay with that. I will post probably like 1 or 2 problems from the textbook. Just kind of like a preview for the exit card. I'm going to try to give like an exit card every day, maybe 2 or 3 problems. Nothing too crazy, just to give you guys some credit for classwork and stuff as we go through this nonsense. All right, here's the last slide, praise God. So for this one, this is using the Directrix to find other values. This is section, I think it's 10.2 in your textbook. Again, hopefully you guys do have those at home, but because I'll probably pick a couple problems from it. But for 10.2, it's, again, the difference between what we did before and what we're doing now with the parabolas is they're using this Directrix and the foci to like use it to do other things. So, basically, because you know what the directrix is, it can, you know, the formula is y equals k plus, k minus 1a. You can plug in your values and work backwards to figure out a. So that's kind of like what the process is here, going backwards to figure out a. Again, you can watch it a little slower on your time, but since excuse me, it's a different color here. Because this is y equals k minus 4a. From this, again, the vertex is hk all the time. So since this is, well, I don't know what that noise was. It's probably a raccoon in the garbage or something. I can't, that was loud. Anyway, that's hk, the vertex. So that means this is 1, this is 8. So, like I said, you're basically just going to take these values, h, k, plug them straight into the equation. You know what y is. It's 3. So it'll be 3 equals k, which is 8, minus 1 over 4a. Subtract the 3, multiply, go through that process to solve for a. You end up getting 1/20th. And then when I write it in full form, this would be that. I don't know why it's not going. Hold on. There it is. Oh well, it waited for me. I guess I didn't time that right. And then for the other one, same process. The vertex is h and k. Plug them in to the appropriate places. So same thing over here. X equals h minus 4a. You know what h and k are because this is the vertex. So h, k go into the right spots here. Solve it. All right. That's what I got. Again, I'll post a little bit more notes on Classroom in a video. Have a fabulous night.